Alright, so now we're going to be getting started on example 4, which is graphing piecewise functions, which is super fun, so get pumped up. So before we start graphing, I'd like to label the parts of our piecewise function. So the parts that deal with the x values, remember those are the intervals that the x values are allowed to go on for each part of the piecewise function. So these are going to be the x values on our graph. Alright, and then these numbers right here are going to represent the y values on the graph. Alright, now, before we get graphing, I like to draw little dashed lines around our intervals so we know which sections each part of our piecewise function are allowed to go on in our graph. Because if you remember, our piecewise functions do not get graphed on the entire graph. They're only allowed on the intervals of the graph. So I'm going to draw dashed lines on the numbers that are in our intervals, which in this case they're actually going to be the same numbers. Since each of them are centered around -1, I only need one dashed line. Now in our next example problem that we're about to tackle, which will be fun times, we're going to have more than one number here, so we'll have more than one dashed line. So first I'm going to start by drawing a vertical line. Since these are x's, it's going to intersect the x-axis at -1. So I'm going to draw a dashed line at -1 on the x-axis to show where my functions are allowed to occur on, which intervals. Alright, now before we get to graphing this lovely function, let's call our green function is going to be interval 1, which this will be section 1 of the graph, and our orange part of the piecewise function we'll call section 2. And we'll talk a lot about why the part 1 of the piecewise function is only allowed on this side of the graph and why part 2 is only allowed on this side of the graph. So the reason why part 1, my green equation in our piecewise function, the reason why this one occurs on this section of my dashed line is because the x values are less than or equal to -1, which if you look on the x-axis, these are all numbers like -2, -3, -4, which these are numbers that are less than -1. Okay, and then the numbers on this side are things like 0, 1, 2, 3, 4, and this part of my piecewise function are the values where x is greater than -1. So these numbers on this side are larger than -1. So the orange function is going to occur on this side of my dashed line, and the green function is going to occur on this side of my dashed line. Now, when we graph these, which in our next example, it's going to be a little different, but when we're graphing these, my y values do not contain x's. So what that means is that they're going to be a constant function, which means they do not have a slope. They have a slope of 0. So this means no matter what x is, it could be -5, it could be -100, it could be -1 billion. It doesn't matter. No matter what your x is in this interval, the y value is always going to be 4. Now, whenever we start graphing, we start on our interval number. So I'm going to start at -1, and since it can equal -1, since we have that line underneath it, that means we're going to have a bubble at -1. And this is where the y value is -4. So my first point is going to be at -1, 4. Okay, so for my green function, if we make a little table, we're going to start at the interval number, which is -1 on the x. And again, no matter what the x is, the y is always going to be 4. So my y value is 4. And I might just come up with 2 other points just to get a nice set of points for my graph. So numbers that are less than -1 are things like -2, -3, -4, etc. So I'm just going to pick -2 and -3. Why not? Alright, and no matter what my x value is, according to this function, since there's not an x in my equation, just a number, the y value is always going to be 4. So the 3 points I'm going to plot are at -1, 4. They are at -2, 4, and at -3, 4. So I'm going to start by plotting my 3 points. So I have one at -1, 4, 1, 2, 3, 4, And I'm going to put a closed bubble because on here it can equal -1. Now, all the other numbers that aren't on your inequality are always a closed bubble, no matter what. So all these points are closed bubbles. The only ones we have to worry about are the ones that fall on the dashed line. So everything else is a closed bubble. So I have one at -2, 4, and -3, 4. And since this is a constant function, it should be a straight line because it does not have a slope. It should be a horizontal line. And it is extending in the negative infinity direction because these are all the x values that are less than -1. Alright, now we're going to do the same thing with my orange graph. Alright, so I'm going to make my little XY chart for the orange graph. Alright, and again, we always start at the number in our inequality, so I'm going to start at -1. And according to this function, no matter what, my y value is always going to be -2, no matter what it is. So I'm going to pick -2. And usually we like to pick about 3 numbers to help us graph. So I look over here to determine which numbers I'm going to pick. So these are all the numbers larger than -1. Now I know that you're probably like, what are you talking about, Miss Long? Why is there a -1 in my table when it cannot equal -1? Well, when we graph this, this is our start point. Now it's not going to equal this number, so when we graph it, there'll be an open bubble, but this tells us where we start, so we are still going to include it in our table. So 2 other numbers that are larger than -1 are things like 2 and 3. If you look over here, 2, 3, 4. So I'm just going to pick, I don't know, you could pick 0 as well. I'm just going to put 0 and 1. Why not? These are numbers that are greater than -1. And according to this function, it says that no matter what, it's always going to be -2 on the y, no matter what the x is. So both of these will be -2. Now, the only one you have to check yourself on is this first one, when we're plotting our points on the graph to determine if it's open or closed bubble. But before we do that, my 3 points I will be plotting are -1, -2, 0, -2, and 1, -2. Alright, so the only one I have to worry about is this number in my interval. So since this one cannot equal -1 because there's not the little line under it like this one at this point we're going to do an open bubble. So since this is the same number as my inequality, okay, and it's going to fall on the dashed line, that's the one I have to determine, is it open or is it closed? So this one's going to be an open bubble because it cannot equal it. So at -1, -2, it's going to be an open bubble because it cannot equal at -1 on the x. This is -1. Alright, but again, any numbers that are not on your inequality above, on your interval, those are always closed bubbles. So these 2 points are going to be a closed bubble. So I would point at 0, -2, and at 1, -2. And they are closed bubble because they're not on my inequality. Alright, and I know it's going to be a horizontal line because it doesn't have an x, so it is a constant function, so it'll be a horizontal line. And voila, we have our lovely piecewise function graph. And I love to name my piecewise function because it makes it more fun. So this will be Polly the piecewise function. Alright, hope you learned how to graph some piecewise functions.